Okay, there are two main types of special sequences. So the first type we're working with here is arithmetic sequences. Arithmetic sequences are going to be like our linear sequences. They increase by a constant amount. So we like add 2 each time, or maybe we take away 5 each time. But they're increasing with a certain linear pace, okay? Just the same number each time gets either added or subtracted. So let's write that down. So it's a sequence, so it's a list of numbers. A sequence, so a list of numbers where each term differs from the previous by a fixed number. Here is an example of some arithmetic sequences. So here an example would be 5, 3, 1, -1, ... So in order to show that this is an arithmetic sequence, we need to look at the difference between the terms. So to get from 5 to 3, we'd have to take away 2. In order for this to be arithmetic, that pattern needs to continue. Okay, 3 minus 2 is 1. Continues to check out. 1 minus 2 is -1. Okay, we're good to go. This is an arithmetic sequence with a first term 5 and a common difference of -2. So let's see. First term, from our last video, u sub 1 means first term is 5. Common difference, which we're going to call D, is 3. Oh, nope, -2. -2. I don't know where the 3 came from. -2. That's our common difference. That's how it changes. First term is 5. Every term after that gets smaller by 2 as it goes. Okay, here's another example. How about 6, 7.5, 9, and 10.5? Keeping my commas different from my decimal points. So, how much does this increase or decrease by? It is increasing, so we should be adding a certain number each time. So, what number are we adding? So, to get from 6 to 7.5, we add 1.5. And then we look to see, does that continue? 7.5 plus 1.5 is 9. Good. Add 1.5 again. Check. That's 10.5. So, we are increasing by 1.5 each time. So, my key pieces of information: u sub 1 means my first term is 6. U sub 1, first term is 6. My common difference, which we decided was D, is the number that it changes by each time. This time it's positive because it's adding. It's increasing by 1.5 each time. Alright, so what is a non-arithmetic sequence? So those two are examples of arithmetic sequences. So how about a non-example? So a non-example would be 1, 2, 4, 8, 16. This sequence has a pattern, but that pattern does not have a common fixed number that's added or subtracted each time. So to get from 1 to 2, you would add 1, but to get from 2 to 4, right, you have to add 2, add 4, right, add 8. So we don't have a common thing we're adding or subtracting. This is actually a multiplication problem. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. This is not an arithmetic sequence. And in the next couple days, next class period, we're going to talk geometric, and that's what this one is. It's the multiplication kind, okay? So that's the geometric. So, I told you in the last video we'd learn how to write some general terms. So our general terms from the last was this piece right here. So we'd like to be able to be given a list of numbers and come up with a general term so that we could generate the sequence for as many terms as we like. So we want to come up with a general term from a list of numbers. So in your IB reference booklet, which I don't have one up here with me. But in that booklet, you have a list of formulas, and this is one of them. I'm going to go grab a book, and I'll be right back. So yours is lime green, but this is your formula book. And under topic 1, which is what we're working through right now, topic 1.7, we have the nth term of an arithmetic sequence and the sum for an arithmetic sequence. This is the one we're concerned with today. When we talk sum, that's series, and that's later on in the chapter. But right now we're worried about this one. So we'll copy that general term down. But this is in your IB reference booklet, which can be used on both exams. So let's talk about what each of these means. So the use of n is it's where you can figure out any value for any term you want. The n represents whatever value you're talking about. So this, just like in the last section, this is the value of the nth term. U sub 1 is your first term. N is your term number. So like 5th term, 6th term, 7th term, I don't know, 100th term, whatever you want to find. And D is your common difference. Those are the key values in this formula. So I'm going to write a sequence, and we're going to come up with, we're going to answer a couple different questions about it. So first thing, is this arithmetic? So it has to have an increase, has to be increased or decreased by a certain number each time. So to go from 2 to 9, we add 7, and then we check to see if that continues to work. 9 plus 7 is 16, good. 16 plus 7 is 23, so far so good. And 23 plus 7 is 30. So there it is, that is an arithmetic sequence. So to write my general formula, which is going to be the first thing that we want to do, our general formula, when we look back here, had an n in it, so we could plug in a term value, and it left this as u sub n, so we could find any term we want given the term value. So whenever we write our general form, here we're still going to have the same things that we don't know. So u sub n equals, we know the first term of our sequence. The first term of our sequence is 2. Plus, I'm following the formula here, n minus 1, leave it like that, and d is my common difference, so times 7. This is my general form. You can simplify it a little bit, which will make it a little bit easier to work with, but this is fine. You can leave it like this as well. To simplify it, we can distribute the 7 into the parentheses. So we get 7n minus 7. And then we put the 2 and the negative 7 together. 7n minus 5. That's our general formula for that sequence. Part B, we are going to find the 100th term. So, one way you can do this, you forget how to use the formula. We can find the 100th term by going 2, so we can follow what I'm doing with my calculator, plus 7 gives me 9, plus 7 gives me 16, right? 3rd term, 4th term, 5th term, 6th term, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th. Now, we have to count to 100, right? 16th, 17th, 18th, 19th, 20th. So this seems really, really tough, right? Not really like hard, but time consuming. So that's where our formula comes in handy, is we can go back to our general form and find the 100th term. So I'm going to go back to this form I found. U sub 100 is going to represent my 100th term is equal to 7 times 100 minus 5. So that's 700 minus 5, which is 695. So if I start at 2 and I keep adding 7, first term, second term, right? Keep on going. The 100th term in that sequence will be 695. Okay, we're going to keep working with the same sequence. I just have to, I'm out of paper, so I'm going to flip over here. Okay, so next piece, C. Okay, so this question is 828 a term in the sequence? Okay, so, wow, the 100th term was 695, so we'd have to go bigger than that. So, you know, maybe the 150th term, 200th term. So how can we figure this out? I'm going to show you multiple methods to figure out whether this term is in the sequence. So the first method, we can guess. So we know that the 100th term is 695. So we could check what is the 150th term. So 7 times 150 minus 7. We're following, or minus 5. We're following our formula here. Plug in 150. Okay, that's too big. So let's go smaller. So 125. Okay, the 125th term is this. So this is still smaller. So how about the 120th term? Oops, still too big. So let's go down again. 119th term. Oh, look at that. Okay, so is it a term? Yes. The 119th term is 828. Okay, that's a way. That works. Maybe it's a little bit more work. So what's the algebra way? The algebra way is we take our general form. We want the output to be 828. We want to figure out what value, what term in the sequence would give us 828. So we solve this little linear equation. $833 divided by 7 is 119. Okay, so 828 is the 119th term. So what would this look like if we had a value that wasn't a term? So D. All right, that's a really big term. So we could go back to our guessing and checking strategy. Let's see, there's our deal here. I don't know, what's the 500th term? Ooh, too big, right? So then we keep going back, smaller. Okay, still need to be smaller. Ooh, a little bit smaller. Ooh, bigger. Okay, this is kind of exhausting when we're up at this high of values. 340. Oh, that's really close, right? Okay, so we're at 2, 3. So maybe we try just work our way down. 39. Still too big. 37. Still too big. Oh, we're almost there. And whenever I go one term smaller, this number, 2,341, is between these two. It's between my 335th and my 336th term. Okay, my 335th is 2,340, and then this one's just a little too big. So that's showing that this is not a term in the sequence because it falls in between these two. We only have whole number terms. So this is the guess and check way, the guess way, I guess. The algebra way is to do the same thing we did above. Set our general form equal to 2,341 and solve. Divide by 7. 2,346 divided by 7 is 335.14. So we don't have decimal terms, we have whole number terms, so no, that is not in our sequence. That would have to come out as a whole number. All right, so we have a couple more questions. I know this video is kind of a long one. Just stick with me here. I'm going to write some terms that have an unknown variable in them. Find k given 3k plus 1k and negative 3 are consecutive terms in an arithmetic sequence. So consecutive means that they're in a row, they're in a line. They go here, there in a line, and we want to find what k would be in order to make this happen. So something we know about arithmetic sequences is to go from one to the next, you have to add or subtract a common number. In addition, if I take the middle one minus the first one, so I'll do a little, this is kind of a side example here, 5, 9, 13. A little side example. If I do 9 minus 5, middle minus the first, I get 4. If I do the last minus the middle, I also get 4, which is my common difference. Okay? That minus that. So if I have three terms that are in order, A, B, C, B minus A is equal to, this one minus this one is equal to C minus B. Those values would find your common difference, and your common difference through an entire sequence has to stay the same. So we know that in an arithmetic sequence, B minus A equals C minus B when A, B, and C are in order. A, B, C. This minus that should give me the common difference, which should be the same. So for this, we've got three terms that are in order. We've got our first term, second term, third term. A, B, and C. So B is K minus A is 3K plus 1 equals C is negative 3 minus B, which is K. And now we have a little linear equation that we can solve. So we distribute the negative, put our like terms together, add the 2k over, and add the 3. So k would be 4. So how could we double check to make sure that that's right? Well, if I plug in 4 here, 3 times 4 is 12, plus 1 is 13. 4 here, and then negative 3. So to get from 13 to 4, you take away 9. No, you take, hold on. Yep, take away 9. What did I mess up? Oh, I see what I messed up. Silly, silly, silly. That negative has to be distributed here as well. So that's a negative 1. So whenever we get down here, we add the 3 to our negative 1. That's 2. Alright, we all make mistakes, right? So that should be a 2. So now whenever we plug them in, 3 times 2 is 6, plus 1 is 7. That should be a 2, and then negative 3. Now let's see if that works. So 7 minus 5 is 2. 2 minus 5 is negative 3. So that is an arithmetic sequence. This value of k makes it an arithmetic sequence. So it works. All right, we've got one more example. So find the general term, u sub n, for an arithmetic sequence with u sub 3. This means our third term is 8, and our eighth term is negative 17. In order to find the general term we need u sub 1 and d. We need our first term and our common difference. On this, I like to do the kind of visual method. First term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term. So my third term is 8, that's what this says, and my eighth term is negative 17. The reason I like the visual method is we can start kind of coming up with some ideas about what's happening. If I'm going to start here at 8 and get to negative 17 there, I know I'm subtracting, so it's getting smaller. Okay, so that helps, but smaller by how much? So to go from 8 to negative 17, we have to add the same thing 1, 2, 3, 4, 5 times. So I'm going to write a little equation that represents this. So I have to add, this would be my difference, I have to add something 5 times to get from here to there in my sequence. So 8 plus 5d equals negative 17. This could be 8 plus 1, 2, 3, 4, 5. Right? That's where you could start. You're adding the same thing, the common difference, 1, 2. And you know you're subtracting, so it should come out negative whenever we get our final answer, but that is what we're doing here. We are subtracting. We are adding, or you can say adding or subtracting, doesn't matter, the same thing 5 times. Okay? So now we solve this. Subtract 8. 5d equals negative 25. So d is negative 5. So that means that my common difference is negative 5. We are subtracting 5 each time. So 8 minus 5 would mean this term would need to be 3. 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7. Negative 7 minus 5 is negative 12. And that does check out because negative 12 minus 5 is negative 17. So this does work. We found our common difference, d. The other piece we need is our first term. So if I subtract 5 to go to the right, then to go back, I have to add 5. So this would be 13, 18. And there we are. This is our sequence. This is our sequence. We have a common difference. We found our first term, u sub 1. And so to write the general form for this equation, we can use the formula that's provided for us in the IB booklet. And our general form, u sub n, our first term is 18. We leave the n, and our common difference is negative 5. It's best to simplify when you can, to distribute that negative 5 back in. And combine like terms. All right, this is a big section, so please let me know if you need some help. I hope that maybe some of this you've seen before. Algebra 1 does a little bit with sequences, arithmetic and geometric both, but please let me know as you need some help.